to delete as earliest as possible. Uh, how could we I'm going to teach measures of central tendency and dispersion in detail. So let's begin the meaning of what is the central tendency. In statistics, central tendency is the overall descriptive summary of the whole data set. If a researcher wants to have you can say a certain set of data, and he has to measure you can say a single value, or he has to calculate a single value, then measures of central tendencies will be used in statistics. The main purpose of central tendency is to provide an accurate description of the entire data in the distribution. The measures of central tendencies has been listed below, that is the arithmetic mean, median, mode, geometric mean, and harmonic mean. In terms of mathematics, the central tendency gives statistical measures that represents a single value of the entire set of data, or in other words, we can say the data set. So let's begin from the arithmetic mean. Arithmetic mean is one of the simplest measure of central tendency. It is a sum of all the frequencies divided by the number of the observations. So it is simply called a mean, or we can say it can be defined as a sum of all the observation divided by the number of observations. So mathematically, the formula stands for x bar. It's sigma x by n, where x is a observation and n is a number of observation. If we state that 1, 2, 3, 4, that means the summation of 1 to 4 in numbers, and what is the number of observation? That is 4. So once you divide the sum of observation from the number of observation, you will get the mean. So the further slide, you will get to know numerically how to calculate using the various methods of arithmetic mean. For the frequency table, let's say for the you can say discrete data or the continuous data, this is the formula stands for, that is x bar is equal to sigma fx by f. That is, f stands for, you can see the total frequency, or sigma f stands for a total frequency, whereas the x is a value of observation, or in other words we can say the class mark. Next is frequency, that is f, that is the frequency of unlimited numbers or items of observation, or we can say class interval. There is another method to calculate the mean, that is a shortcut or step deviation method. In this method, the mean is obtained like x bar is equal to a. A stands for assumed mean, plus that is sigma fdi by sigma f into h, where we can say n, or n is a total frequency, or sigma f is a total frequency. D stands for deviation, that is the difference between the values of observation and assumed value from the list of observation, that's called deviation. And D stands for deviation. H is a width of class interval, or in other words, we can say it's a difference between among all the class intervals. For example, if we say 10 to 20, 20 to 30, 30 to 40, that what is the common difference of all the class interval is 10. So 10 is H. Deviation stands for, again, a difference between the values of observation and assumed value from that observations. Median. What is median? Median is another measure of central tendency. It is being calculated either quantitatively or qualitatively. It is, in other words, we can say the median is a middle value of all the observation which has been arranged into an ascending or descending order. So mathematically, there are two categories where the number of observation or a total frequency is odd, where the number of observation or total frequency is even. So there is a formulas has been divided into two parts. So where the n is odd, the formula how to calculate the median is the value of, that is, n plus 1 by 2 item or the term. When the n, that is the number of observation or the total frequency is even, the median, how to calculate the median is the value of n by 2 item or term plus the value of n by 2 item plus 1 by 2. That this formula will be applied if the n is even number like 36, 42, in fact 12, 6, 10. So when these even digits would come into your quotient, the formula you have to use like this: n by 2 item plus n by 2 plus 1 by 2. When we talk about discrete or continuous data, median is an observation of n by 2. So in terms of continuous data, we use the formula n by 2. If we talk about the individual or raw data or discrete series, we talk about the n plus 1 by 2 item or term. For the class interval, when we talk about for the class interval or continuous data or continuous series, the median is obtained by, in the following formula we have to use, then mathematically L, that is lower limit, plus n by 2 minus C is, you can see, a cumulative frequency by f0, that is the frequency of the median class, into C or H, that is the same thing. It's a common difference of among all the class interval, or in other words we can say H, that is the width of median class or a difference between the class interval. I repeat once again, L is the lower limit of the median class or class interval. F0 is the frequency of the median class. C is the cumulative frequency before the median class. For example, if the cumulative frequency comes under 235, that means the C would be 235. H is the common difference between the class interval or width, or in other words, we can say width of median class. What is mode? Mode is also the another measure of central tendency. In other words, we can say mode is also being used for a qualitative and quantitative data. It represents the highest frequency in a data set. So the value which occurs the highest number of times, that value is called mode. For a raw or discrete data is the value which comes the highest in number, that value is called mode. In the continuous or in case of class interval, the data will be represented in a continuous series and it will be calculated using a different formula that is given on the screen. That is L0, that is lower limit, plus F minus F1 by 2F0 minus F1 minus F into H. So F1 is a frequency before the mode class, F1 frequency after the mode class, F0 that is the frequency of mode class, and the H is common among the all measures of central tendency, that is the difference between among the class interval or the width of a mode class. L is the lower limit of mode class. If the two values occur same a number of times, that data is called bimodal. So the two values which comes under the value are called a mode. That two values will also be considered as mode. In other words, theoretically, it is called bimodal. Let's talk about the relationship between mean, median, and mode. The main relationship, mathematically, we can say the mean minus mode is equal to 3 by x bar minus median. Or in other words, we can say mode is equal to 3 median minus 2 x bar. These three terms, mean, median, mode, interrelated to each other, and if we talk about the symmetrical distribution of a data set, these three terms will always be equal. That is, mean is equal to median and mode. Mathematically, it's an equation, we can say, where the x bar, that is mean minus mode, is equal to 3x bar minus median. Or in other words, the mode will be calculated from the first equation, that is 3 median minus 2 mean. Let's talk about the example now. So whatever the three terms, that is mean, median, mode, and using the different methods, let's talk about the full-fledged quotient so that accordingly it will be calculated. So following are the article activates partial thermoplastin time for 35 patients. So these are the particular, it is called a raw data given to you. You have to calculate the mean. So when the raw data has been given to you and it already given, it's a 35 patient, means that 35 values has been given to you. Or you can say the values of observation or the number of observations. So this is a way that how to calculate the mean. The mean is calculated for the raw data, that is sigma x by n. That is, x is a summation of all the values which comes under 1187, and n is a total number of observation, which is 35. If the 35 in the question is not being given, and from the data itself you can easily calculate the number of observation is 35. That is, if you can see gone through the table, it stands for 35 patients. So accordingly, n is also 35. So x bar is 1187 by 35. You will get the mean, that is 33.91. I repeat once again, when we talk about the raw data and individual data, so the formula which stands to calculate the mean, that is sigma x by n. N is the total number of observation and x is the sum of all the observation, that is 1187. So when you add all the values, you will get 1187, and when you divide from 35 to 1187, you will get the answer, or you will get the mean, that is 33.91. So this is a case of a raw data. This is a case of an individual data. This is a case of an individual series. Let's talk about median. So when we case about the raw data or an individual data, or it means that you have to arrange the data into an ascending order or descending order. See, it is choice is of a learner that either the data could be assigned into an ascending or descending one. So this is a data has been given to you, an individual data or raw data. So your learner has first task is to arrange into an ascending order. So this data, if you check, this has been assigned into, in both cases, you can easily calculate in case of raw data, median and mode. So number of observations. So if you count, it doesn't it doesn't shown that it is a 35 patient or it is a 40 patient. So if in the question it is not given that it is a 35 patient, from the raw data you can easily estimate the total number of observations. So this is a 35. So number of observation is 35. So you can easily imagine it is an odd number. So in the odd number, you have to use the formula, that is median, that is n plus 1 by 2. So if the n, that is the number of observations or number of items, stands odd, the formula that you have to use, that is the n plus 1 by 2. So if the n is 35 plus 1 by 2, you will get the 18th term. So 18th term, it means from the data, the value which comes under 18th term is the value of the mode. So let's begin from the data. So let's begin 1, 22.30, 22.80, 29.30, 35, 45. It's a 5 observation. In the next row, again 5 observation. In the next row, again 5 observations. So the total term or a total observation till here, it's 15. So we have to check on 18th observation. We have to check the 18th term, then what value comes under 18th term. So till 15, that is 46.510, 16 observation is 22.10, 17 observation is 24.90, and 18th observation or 18th term, it's 31.20. It means on the 18th term, the value of mode is 31.20, and that would be the answer of the value of median, that is 31.20. So in the next part, you have to calculate the mode. So you have to check from the series of the data or a raw data that which value comes the maximum number of time. It would be either 20.30, it would be either 20.70, it could be either 29.70, it could be either 41.60. So just you need to check that which value comes the highest number of frequency and highest number of observation, or you can say in other words the value which comes the maximum number of time. So if you check from the raw data, it would be it's 46.10, 46.10, 46.10. So there is a one value which occurs or comes 3 times, and that is the 46.10. 46.10 is called mode. Why it's called mode? Because the same value comes 3 times, and the mode, what is mode exactly? The mode says the value which occurs the maximum number of times is the value of mode, and that's called 46.10. So this is the mode. So the value is 46.10. So in the given data, you can easily see that the value that is 46.10 occurs 3 times, and that value is called mode. So let's take an example, another example, that is the continuous data. That is the following data has represents the wages irrespective number of workers. Calculate the different measures of central tendency. It means in the continuous series, the learner has to calculate mean, median, and mode. So this is the data given to you. So let's begin. So this is the calculation of mean in case of continuous series. So if the values or if the frequencies has been in large in numbers, in 100 or more than 100, so it means you have to calculate the mean in using the step deviation method or shortcut method. But in this case, the number of frequency is not so large. The number of frequency is not large actually. So that means you have to simply use the formula of mean, that is sigma fx by n. N stands for total frequency, or sigma f is also stands for total frequency. So in this particular series, how to calculate the mean? That is sigma fx by sigma f. Fx is like frequency into x. What is frequency over here? In the question is already given to you the frequency, that is the number of workers. But what is, you can see x. X stands for class mark. What is class mark? It's called, in other words, we can also call a midpoint. Midpoint, how to calculate the midpoint? So you can in the question you can see that the upper limit plus lower limit by 2. When the series begin, from all the beginning, you can see series are called the lower limits. The series and the number which ends the series, that is called the all the numbers, that is the upper limit. That means 170 plus 180 by 2, you will get 175. That is the midpoint or class mark. If you talk about upper limit plus lower limit by 2, that is class mark, that is 190 plus 180 by 2, that is 185. 190 plus 200 by 2, that is 195, and so on. So once you get the frequency and the class mark, you have to multiply the both one by one. That is frequency into x. That is 52 into 175. You will get 9100. 68 into 185. You will get 12,580. If you multiply 85 into 195, you will get the 16,575, and so on. So once you calculate the mean, you use the formula, that is sigma fx by sigma f, that is the 12,000, you can say 12,000, 12,3350 by total frequency, that is 590. You will get the mean, that is 209.07. So that is called how to calculate the mean in case of continuous series. Let's talk about the calculation of mean, where you have to use, where the data is of big multiplication, where the data uses the highest number of values, where the frequency is very large in numbers. Then a step deviation method has to be used to calculate the mean. What is the formula of step deviation method? In the previous slides, I already taught you that how, when you use the calculate the mean, the step deviation method. This is a method of step deviation. There is another way to calculate the mean. It means when the big calculation with multiplication values has been there in the data, that means a particular learner or researcher has to use the step deviation method manually. That is, the x bar is equal to a plus sigma fdi by sigma f into h. That is, you can see h is or also an I or c is a common difference among all the class intervals. So that is c or h. So let's begin with the question over here. Yeah. So to calculate the mean, if you see from the mean itself, there is another method to calculate the mean where the big multiplications has been there. So then you have it is compulsory to use step deviation method. When we talk about the main purpose is in under step deviation method to calculate d in case of continuous series, that is x minus a by h. That means x is whatever the mid values or whatever the class mark has been calculated. You have to deduct assumed value. Assumed value means the value which is being assumed from the class mark itself, and one by one its assumed value will be deducted from the class mark or the mid values, and that's called deviation. So in continuous series, once you get the difference of the midpoints or the class mark and the assumed value, just divide by h. H is a common difference, or you can see a width of class interval among all the class intervals, that is 10, 15, 20 as a maximum difference. So this is a table which has been shown. The same question has been considered, that wages has been given to you in the question, frequency has been given to you in the question, but you need to calculate the mean using the step deviation method. The step deviation method stands for the A, that is the you need to calculate the A, that is assumed value, right? Then on the assumed value, you can easily calculate the lower limit. So once now we have to focus in the following terms, that is M. M stands for class mark or mid value or midpoint. So how it would be calculated? So that the same formula to be used, that is upper limit. M stands for, that is upper limit plus lower limit by 2. So once you add both the class interval and divide by 2, you will get the midpoint. So 170 plus 180 by 2, 175. 180 plus 190 by 2, 185. 190 plus 200, 195, and so on. How to calculate the deviation? The formula is given on the screen, that is midpoint minus assumed value. What is assumed value? From the midpoints, you have to choose the central value, which is called the assumed value. So that is 205. You can choose 205 or you can choose 215. It's any value you can choose, but it should be the central value, because it shows you can see a true description of a data set, or in other words, you can say accurate description of a data set. And that's why we choose the central value. We did a central value which is called an assumed value. So in this particular question, it assumed 205 is the assumed value, that is A. So one by one, you have to deduct 205 from all the values of the midpoint. 175 minus 205, it's 30. But what is the formula to calculate the D over continuous series to calculate the mean? That is X minus A, which is X is called M, A is the assumed value, by H. H is a common difference between all the intervals, that is 10. So 175 minus 205 by 10, it's minus 3. 185 minus 205 by 10, minus 2. 195 minus 205, it's 10 divided by 10, it's minus 1. 205 minus 205 is 0. 215 minus 205, it's 10 divided by 10, it's 1. So this is the formula. This is the formula which has been shown on the screen, and the same formula will be used to calculate the D. So once you get the D, all the values, just multiply the D with the frequency, that is FD. So F is 52 minus 3 into minus 3, that is minus 156. 68 into minus 2, minus 136. 85 into minus 1, that is minus 85, and so on. So FD, the summation, the sum of FD is 240 and the sum of frequency is 590. So what is the formula of mean? That is A. A is a assumed value. What is the assumed value? That is 205 plus 240 FD by sigma FD by sigma F into H or C. That is a formula of mean. That is A plus sigma FD by sigma F into 10. It means you will get the mean, that is 209.07. So A is 205, sigma FD is 240, which has been calculated in the table. Sigma F is again 590 into 10. That is 205 plus 4.05, it is equal to 209.07, and that's called mean. Now we continue over median and how to calculate the median in case of continuous data. So this is a question has been given to you. To calculate the median, you need to calculate first the n by 2 item. That is, it is mean calculated 295. So n is 590. Just divide by 2, you will get 295 item or term. This is not a value of median. It is the term, 295 term. And from the 295 term, you need to calculate the median, and there is a separate formula to calculate the median which will be used in the following question. This is the formula which has been used in case of median. What is the formula of a median? That is L0, that is lower limit, plus n by 2 item. N by 2 item, that is 295, minus CF. CF is a cumulative frequency by frequency, summation of frequency, that is and into H, that is C. So let's begin the question. This is a continuous series has been given, that how to calculate. First you need to calculate lower limit. So how to calculate the lower limit? Lower limit, that is calculated from the class intervals, that is wages has been given. So 1 n by 2 item, that is 295 item. You need to calculate to check the n item or term, that is cumulative frequency. How to calculate the cumulative frequency? That is the summation of the frequency from 1 by 1. That is 52 plus 68, 120. 120 plus 85, 205. 205 plus 92, 297. So and so on. Just add it one by one, you will get the cumulative frequency. You need to check, you can verify by own self that the cumulative frequency total, that is 590, and the frequency total, that is 590, should be same. And that's called the verification of your calculation of total frequency. Now we have to check the 295 term. You need to calculate the class interval, that is lower limit. You need to calculate the lower limit as per the formula. So 295 term or item has been calculated. So you need to check from the cumulative frequency. You need to check that 295 comes under which two values of cumulative frequency. So let's check, it's 205 and 297. These are the two values where the 295 occurs between or lies between these two values, that is 205 and 297, right? So your next step is to calculate the lower limit. That is how to calculate. So 205 cannot be considered because it is lower than the term value, which is 295. So the lower value cannot be considered in this case. So what would be the balance value cumulative frequency? That is 297. The two values has been considered where the 295 lies. 205 will not be considered because it is less than the 295. So always be used which is more than the term value, that is 297. So once you calculate the cumulative frequency which lies 295, that is 297, the lower limit would come easily, that is 200. So 200 is your lower limit, that is called L. So 200 is your lower limit. Now we talk about the cumulative frequency. Let's we talk about the cumulative frequency, that is C. C, that is 205 will be considered because 295 lies between two values. 297 is already considered to calculate the lower limit. So what would be the left? That is 205. So 205 is your C, or in other words CF. Let's talk about the F, that what would be the value of F and how to calculate the value of F. So whatever the lower limit has been calculated as 200, the frequency will be the same frequency comes under 200, 210, that is 92 will be F, that is F is 92 and H is 10. How the H is 10? H is 10 is a common difference among all the class interval which is 10. So the formula says median, that is lower limit L plus 295, that is n by 2 item or term, minus C. C is a cumulative frequency by F into 10. By F is 92, H is 10. So once you put the values into the formula, you will get the median, that is 209.78. I repeat, the formula stands for that how to calculate the median is lower limit plus n by 2 item or term minus C or CF by F into H or C. Is H or C is a width of the class interval, or you can say a difference between or a common difference of the class interval, that is 10. So once you put all these values into the formula, you will get the median, that is 209.78. This is a mode. So mode is very easy to, and one of the simplest method to calculate the mode, because it is a class with the maximum frequency occur. So when you look at the question of continuous series, you need to check that frequency, that is the number of workers. So which is the highest frequency? That is 100. So it means it is a mode class, because mode classes which is the highest frequency in the particular continuous data or continuous series, that is a mode class. And what would be the class interval? That is wages. It is easily being calculated, that is 220 minus 230. That means 220 to 230. That is the class interval has been find out to calculate the mode. So once we calculate the mode, in case of continuous series, how to calculate the mode? This is a formula given on the screen. L is a lower limit, F1 F0 by 2F1 F0 minus F2 into I. F1, which is already shown to you, F1, it's given to you. F1 is before the mode class. F1 is a frequency before the mode class, and F0 is the frequency after the mode class. So it's written F0 is a frequency which is the highest frequency, F1 which is called the before the, you can say, mode class, and F1 is after the mode class. So once you get the values put into the formula, you will get the value of mode. I repeat once again, L is a lower limit, F1 minus F0. So F0 is the highest frequency. You can say F1. F1 is the highest frequency, that is before the frequency which has been from the mode class. If the mode class is 100, the F1 is a before the frequency before the mode class, and F1 minus 1 is after the mode class. So once you get the values of all, put the values into the formula, you will get the value of mode. So H is a common difference among all the class intervals. The common difference is 10. So once you get, so separately just estimate the values, you will get the value of mode. So when we talk about individual data and discrete data, the highest the value or the frequency, the value which comes the maximum number of times is the value of mode. But when in case of continuous data, there is a formula which is being used to calculate the mode, that is the L1 plus F1 minus F0 by 2F1 minus F0 minus F2. So the same formula has been used over here. Let's talk about the measures of dispersion. Measures of dispersions are the, you can say, it is based on giving up the central point around which the data is concentrated. It is used by mean, it is used by standard deviation, it is used by mean deviation. So to use dispersion, if we talk about the mean deviation, it means we use the mean, we use the median. So using the mean and median in the measures of dispersion, where the comparison is being find out, where the variability, where the changes in the data set is being find out, which always give the central mid value or point around which the data is always being you can say concentrated or constructed. The measures of central tendency are alone are not good enough to describe the data completely. If in statistics, or you can say mathematics as well, when we talk about the measures of dispersion, we always use the measures of central tendency, mean, median, mode as well. So measures of central tendency are not alone enough to describe the data completely. They have to use the measures of dispersion as well in three type of data, that is the individual, discrete, and continuous data. Let's let's take an example over here. The two type of drugs, that is the individual values or the data has been given. You need to calculate which drug would you like to prefer and why. If we talk about drug A and drug B, so how you need to calculate the mean, and from the mean you can easily find out the which drug is more preferable for the users. So mean drug A, the mean is 3.7 hours, and drug B is a mean 3.8 hours. So which value is more? It's drug B. The mean value, the drug B will be preferred as the observation as compared to drug A. So when we talk about the concentration, when we talk about the closer values or scatteredness of the data around the central values only, then the measures of dispersion are used. So these are the measures of dispersion. They are classified into two categories. That is absolute measures of dispersion, relative measure of dispersion, range, quartile deviation, mean deviation, and standard deviation are the absolute measures of dispersion, and relative measures of dispersion, that is coefficient of range, coefficient of mean deviation, coefficient of quartile deviation, coefficient of variation, are the relative measures of dispersion. So let's begin from the absolute. So this is the called absolute measures of dispersion of the first category, that is range. How to calculate range? Mathematically, it's a maximum observation value minus minimum observation value. In other words, we can say the largest value and the lowest value. So it means a difference between the largest value and smallest value is called the range. So range is very simplest, but it never be show a true accuracy of the data set because it is not reliable measure of dispersion. So range is just always show a differences of two extreme observation, which is the highest value and which is the lowest value, and that's called range. Let's talk about the mean deviation. Mean deviation is calculated through the two measures of central tendency, that is mean and median. So your A is either mean or median. The question is always being given, calculate the mean deviation by mean. Calculate the mean deviation by median. This is a formula that a learner has to use. For the raw data or individual data, the mean deviation, that is called sigma x by A. A would be the mean or median or by n. That's called the mean deviation in case of individual data, in case of raw data, in case of discrete, you can say data. But when we talk about any frequency data means it's a discrete or continuous. That means f sigma x minus a by sigma f. That's called the mean deviation. I repeat once again, sigma f by x minus a by sigma f. That's called the mean deviation. In case of frequency data, in the discrete, the frequency is always given. So you use this formula. In case of continuous, this is the formula that a particular learner has to use. So I repeat once again, sigma f bracket में x minus a by n. So mean deviation is called, MD is called the mean deviation. That is a symbol of the mean deviation, which always begin through the origin A. A can be taken as any measure of central tendency at the mean or median or any specified value. When we talk about modulus x, it means the positive signs will remains the positive and the negative signs will become positive, and that's called a symbol of modulus under x variable or a value. So positive value, that means a modulus 3 will become 3. If we talk about the modulus minus 3 will become positive, that is 3. So that is the one of the main important information or a point under mean deviation. Let's talk about the standard deviation. Standard deviation is also another measure of dispersion. It is defined by a square root of the arithmetic means of the squared deviation of the observation from their respective mean. It is the formula which has been shown here in the words definition has been given in the screen. So in case of individual data, we talk about how to calculate the standard deviation, that is root x sigma x minus x bar whole square by n. When we talk about the discrete and continuous data or series, standard deviation is equal to f x minus x bar whole square by n. That is standard deviation. In other words, the standard deviation is also called the square root of the variance. It means under the root, whatever the calculations, whatever the terms has been given, it's called variance. So it means in the discrete and continuous data, that is f sigma f by x minus x bar whole square by n is called the standard deviation under discrete and continuous series. This is called the variance. So variance is used to calculate the average square distance of the observation from their respective means. So for the individual data, it's 1 by, that is sigma x minus x bar whole square by n. In case of discrete and continuous series, f sigma f x minus x bar whole square by n. When we more advanced formula in case of standard deviation, that is sigma f x square minus sigma fx by n whole square. That's called variance. But if we use the step deviation method, only the difference is the formula which is being used, the advanced formula which is being used for the discrete and continuous series, the same formula will be used under step deviation method. The difference is into h, that is square, into h square means that is the common difference between the class interval. If the common difference is 10, so the 10 square would be the h square. So that is under step deviation, difference between the formula of frequency data and the step deviation data. So when we talk about the frequency data, we talk about the discrete and continuous data. So under the discrete and continuous data, there is a method to calculate the variance, and the method is step deviation method, and the formula is almost same. The one difference is h square, that is the common difference between all the class intervals square. So where n is the total frequency, d, what is d here? It's deviation, a difference between the x minus a, or difference between the number of observation and assumed value. A is the assumed value, h is almost width of the class interval or common difference between all the class intervals. So this is the variance and formulas. That means the variance and standard deviation are both interrelated to each other. So the formula is same for both. The difference is the no square root for the variance. For the standard deviation, square root is always there, because that is the square root of the variance. That's called standard deviation. But for the variance is a square. So every value you need to calculate the square. If you talk about the fd by n whole square, that's called variance, because in this you are calculating the squares of all the values. That is called the variance. Quartile deviation is also the another measure of deviation. It is mostly used in the qualitative data, no quantitative data under qualitative deviations. Once you calculate the qualitative deviation, in case of quantitative data, it will not apply. It will apply in case of qualitative data only. In other words, it is also called the semi-interquartile range. Now, how to calculate the quartile deviation? That is, two quartile will be used. That is, the third quartile stands for Q3. That is the first quartile that stands for Q1. So Q3 would be the highest quartile and Q1 is the lowest quartile. So just you can see the difference between the third and first quartile by 2. That's called the quartile deviation. In other words, we can say it's a half distance between the first and third quartile is called quartile deviation. It is one of the better method to check the closeness of the dots, the closeness of the points of the data set, which called the scatteredness in case of rank order data. If you're ordering the data, if you're ranking the data into an ascending or descending order, quartile deviation is one of the good measure to use. But it has a major drawback. It is based on two observations and it always ignore all other values. The two observation is third and first. That means the highest quartile and the first quartile. And for the continuous data, it is not applicable or it is a very less chances to apply this measure in case of continuous data. So when we compare to quartile deviation and standard deviation is more better measurement than the quartile deviation, because standard deviation it always shows the variability of the data set rather than quartile deviation. Quartile deviation is based on the two quartile, the highest and the lowest, the values of the highest and the lowest values. This is one of the example of comparing the two different companies, and out of two different companies there are three cases has been given, that is case 1, case 2 and case 3, and the two different companies with their respective data has been given on the screen. And while comparing the whole data set, you need to calculate the mean and the variance. So in the question, it is already being calculated the average and variance. So when we comparing the whole data set of different two companies and with their cases, that means we use the relative measures of dispersion, that is the standard deviation or variance or mean. So if we talk about the case 1, if the mean values is same, that means any user can use either C1 company or C2. When we talk about the case 2, that is 17 for C1 and 20, it means the more the value of mean, that company would be preferable by the user, or that company will be preferred by the user. In case of case 3, there are or the variance, the whole values are totally different. When the values are different in two different companies or three different companies, either average or variance, it means there is a time to come or to use the relative measures of dispersion. And in the third case, it is very necessary to use the relative measure. It means the coefficient of standard deviation, the coefficient of mean deviations, the coefficient of variations, and that's called the relative measures of dispersion. So this is a whole theoretical aspect. So in case of case 3, the decision will be made with the help of the measures of relative dispersion. That's all for today, and we'll continue with the more numericals on the relative measures of dispersion. Till today, thank you so much and namaste to all.